Hi everyone, I'm Jim. Many of you may know me as Dr. Jim Fan on Twitter. I'm a senior research scientist at NVIDIA, and previously I did my PhD at Stanford. And I used to be Andre and Tim's intern at OpenAI like 7 years ago. We worked on Open Universe and World of Bits, and that was one of the first operations. Very fond memories, and today I want to share a little bit on journalist agents on open-ended worlds. So what environment is more open-ended than Minecraft? Minecraft has got 140 million active players, and just to put this number in perspective, that is twice the population of UK, and 5 times the number of programmers worldwide. So it just so happens that gamers are generally happier than PhDs, so they love to share what they're doing on Minecraft online, and that means 2 things. One is there are lots and lots of YouTube videos that gamers upload. And second, there are lots and lots of Minecraft text and tutorials for GPT-4 to train. And today, I want to discuss a little bit on these ideas. So last year, I led the team to build a framework called Dojo, which is an open source framework to help the community develop generally capable agents using Minecraft as a kind of primordial soup. And I will share 2 ideas today enabled by Minecraft, but are generally applicable to many other domains. So the first idea is about the massive amount of videos capturing human strategies and creativity. So we scraped in my Dojo 300,000 YouTube videos with 2 billion words in the transcript. Like these are actually the real transcript and videos from one of the most popular YouTube tutorial videos on Minecraft. And what we can do is we can learn the association between the video and the transcript that describes the action in the video. So this score goes from 0 to 1. And intuitively, 1 means perfectly aligned. That means the text describes the action in the video. And 0 means the text is irrelevant to the video. So what does that mean? This looks like a reward function, right? And then we can plug in this model called MineClip, which is a reward function, into action. So here, as an example, our agent is interacting with the Minecraft simulator. And the task here in natural language is searching to obtain wool, and as the agent explores, it has a moving window of the video snippet, and you can compute this score from this reward function, and you provide that to any reinforcement algorithm. So what does this look like? This is ROI-trap in Minecraft, reinforcement learning from human feedback. And ROI-trap is the cornerstone algorithm that made ChatGPT possible, and I believe it will also be the cornerstone for building journalist agents as well. So these are some of the videos from trained by ROI-trap in Minecraft. And you can see that many of these tasks are relatively short horizon, about 100 to 500 steps. And that's because the reward function is only able to capture a short horizon. So back last year, the goal of having an agent that explores and makes new discoveries autonomously seems out of reach. Until and his team, GPT-4 came, a language model that's so good at coding and long horizon planning. So correspondingly, we built Voyager, the first large language model powered lifelong learning agent that plays Minecraft for hours on end. And thanks, Sean, for already covering a little bit, so I will quickly gloss over this. So the video here shows snippets from not just multiple episodes, but a single episode of Voyager, and it just keeps going, right? It's always traveling to uncharted territories and finding new things to do by itself, and picking up new fights and solving new challenges, all without human patience. So how do we do this? Right? We want to use the full power of GPT-4. That means we need to stringify things. And the way we do it in this multimodal environment Minecraft is to use this open source framework called MineFlayer, which is a high-level JavaScript API that essentially converts observation of pixels and parses it into text. And then we also take actions as code in text. So this is one example of writing a JavaScript function to attack an enemy using the MineFlayer API. And that will execute in Minecraft. So the key idea of Voyager is to use code to control an embodied agent. And because GPT-4 shows a quantum leap in coding skills, and that's what made Voyager possible. And also JavaScript runs a code interpreter. That means Voyager can actually define new functions on the fly and run it interactively. But the code that GPT-4 wrote may not be correct on the first try, so we developed an iterative prompting mechanism where there are 3 types of feedback. One is execution error from JavaScript interpreter, if you make a syntax error, for example. And the other is environment feedback, like you get a piece of item after executing this action. And another is a critic, again instantiated by separate GD4, that does self-reflection from the agent's own past and its own state. And these help agent refine the program effectively. And then once it implements a skill correctly, we will save it to a persistent skill library. So you can think of it as a code base that's authored purely by GD4 through trial and error. And the agent can retrieve skills once facing similar situations in the future, so it doesn't have to implement and try the skills and debug the skills again. And in this way, Voyager improves itself as it experiments more and more in Minecraft. So this is finally, the final piece is automatic curriculum, where we give it an unsupervised objective of just discovering as many items as possible, and then it automatically discovers that these are the things it needs to do in sequence. And putting all these together, we have an iterative prompting mechanism that's essentially in-context reinforcement learning through trial and error, and then we have an in-context skill library or replay buffer, and we have an in-context way to do exploration. So overall, this is Voyager's no-gradient architecture, where we don't train any new models, we don't do any gradient descent, and Voyager can self-bootstrap and perform lifelong learning in an open network. So please visit our website. I'll just quickly go over this. Some superior performance compared to the baselines, and we see that Voyager is a great traveler, and that's the name. It travels way more than baselines methods. And check out our website. So this is minddojo.org. That's our work from last year, and we got Europe's best paper for this work. And voyager.minddojo.org, where we open source everything, also including the pre-trained skill, the pre-trained quote-unquote skill library that Voyager generates. It's on our GitHub. We also have the MindClip model, that's the foundation of open source as well. And finally, if you want an excuse to play Minecraft at work, this is your perfect excuse. You're doing it for science, you're collecting data from my dojo. And yeah, so just one last thing, I want to remind all of us that despite all of these progress and agents, we're still really far from what humans can do in Minecraft, right? Like these are videos of humans implementing a working CPU inside Minecraft. Because you can use redstone surface, and apparently the game is Turing complete. But of course, it's way beyond the capability of Voyager right now. So let's see if Voyager 2 or GB5 with some no-gradient architecture can finally solve these great challenges. And finally, life is short, so let's do some hardcore AI research and have fun at the same time. And I'm Jim. Thanks.